30 seconds ago, a telescope watching the night sky detected something that should not be there. A massive object from deep interstellar space has just appeared near the path of the strange comet known as 3I Atlas, and astronomers are trying to understand what they are looking at. For thousands of years, humans believed the sky was calm and predictable. Stars stayed in place. Planets followed clear paths. Comets appeared, grew bright, and then slowly faded away. But in the last few years, scientists have realized something surprising. Our solar system is not as isolated as we once thought. Every now and then, objects from other star systems pass right through our cosmic neighborhood. The first confirmed visitor like this appeared in 2017. Astronomers using the Pan-STARRS Sky Survey in Hawaii noticed a strange object moving through the inner solar system. It was later named ʻOumuamua. When researchers at the European Southern Observatory and scientists studying the object through the Hubble Space Telescope analyzed its speed, they realized something shocking. It was not orbiting the sun day. It was simply passing through. That meant it came from another star system. 2 years later, another one appeared. This one looked more like a traditional comet. It was discovered by amateur astronomer Comet Borisov and later studied by telescopes at the Keck Observatory in Hawaii and the Hubble Space Telescope. Scientists named it Comet Borisov. These discoveries prove something important. Interstellar objects are real, and they may be more common than astronomers once believed. But now, a new object may have entered our solar system. And the situation is even stranger, because it did not arrive alone. A massive object has just appeared near the path of a mysterious comet known as 3I Atlas, and the timing has caught the attention of astronomers around the world. To understand why scientists are watching this so closely, we first need to understand how objects like this are discovered. Every night, powerful telescopes scan the sky looking for movement. One of the most important systems doing this work is called ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System. The project is supported by researchers at the University of Hawaii and works closely with scientists at NASA's Jet Propulsion Laboratory in California. The goal of ATLAS is simple. Watch the sky for anything that moves. Asteroids, comets, or objects that might pass close to Earth. The telescopes take huge images of the sky again and again, comparing each picture with the one before it. If something changes position, the software flags it for astronomers to examine. Most nights, these systems detect ordinary space rocks, small asteroids, faint comets, nothing unusual. But every once in a while, something appears that immediately catches attention. That is exactly what happened when astronomers first noticed the object now called 3I Atlas. The first clue that something was unusual came from its speed. Objects inside our solar system move in predictable ways. Their motion is controlled by the gravity of the sunday. When astronomers measure their paths, they normally follow oval-shaped orbits around the sunday. But when researchers began calculating the orbit of this new object, the numbers told a different story. Scientists at the Minor Planet Center, which operates under the International Astronomical Union and works closely with the Harvard-Smithsonian Center for Astrophysics, started analyzing the data. The results surprised them. The object was not following a closed orbit around the sunday. Instead, it was moving along a path known as a hyperbolic trajectory. In simple terms, that means it was not trapped by the sun's gravity at all. It was just passing through. That single discovery suggested something incredible. The object likely formed around another star system far beyond our own. For millions, maybe even billions of years, it could have been drifting through the darkness between stars before finally entering our solar system. Imagine a cosmic traveler wandering across the galaxy long before humans even existed. Now imagine that traveler suddenly appearing in our sky. That alone would have made 3I Atlas an exciting discovery. But the story became far more interesting when astronomers noticed something else. Another object appeared nearby. At first, the detection looked like a normal comet or asteroid. But when researchers began measuring its brightness and motion, they realized something surprising. It was large, very large. Early estimates suggested the object might be hundreds of kilometers across, though those measurements are still being refined as more telescope data arrives. To study something this distant, Astronomers combine information from multiple observatories. Data from the Keck Observatory in Hawaii, observations from telescopes connected to the European Southern Observatory, and spectral comparisons from the Hubble Space Telescope all help build a clearer picture. Even the James Webb Space Telescope, which can detect heat and infrared light from distant objects, sometimes provides clues about the composition of mysterious visitors like this. At first, researchers assumed the new object was unrelated to 3I Atlas. After all, space is busy. Asteroids and comets travel through the solar system all the time. But then, orbital calculations from NASA's Jet Propulsion Laboratory began showing something strange. The new object's path seemed to be approaching the same region of space that 3I Atlas was already moving through, and the timing was extremely close. Close enough that astronomers began running more detailed simulations. Because if two interstellar objects appear in nearly the same place at nearly the same time, that raises an interesting question. Is it just coincidence, or could they somehow be connected? Scientists are careful not to jump to dramatic conclusions. Astronomy relies on evidence, measurements, and repeated observations. Still, even cautious researchers admitted the situation looked unusual. The sky is enormous. The distances between objects are typically millions or even billions of kilometers. For two rare interstellar visitors to appear near each other is something astronomers do not expect to see very often. Teams at the Harvard-Smithsonian Center for Astrophysics began comparing the light coming from the objects. By studying how light spreads into different colors, scientists can learn what materials are present on distant objects. Ice reflects light in one way. Rock reflects it differently. Carbon compounds create their own unique signatures. Early observations suggested that 3I Atlas behaves somewhat like a comet. It appears to contain frozen gases that can slowly evaporate when sunlight warms its surface. But the second object looked different. Its surface appeared darker, less reflective. That could mean it is made mostly of rocky material, or that its surface has been heavily altered during a long journey through interstellar space. Scientists at Stanford University even began reviewing older radio astronomy concepts, including ideas originally discussed by Ronald Bracewell, to see if unusual radio signals had ever been detected from objects like these. So far, nothing unusual has been confirmed. Still, the investigation continued, and then something else began to appear in the orbital data. The new object was not just nearby. Its path seemed to be slowly bending toward the trajectory of 3I Atlas. At first, astronomers assumed this was just an early calculation error. Orbital predictions often change when new observations are added. But as more telescope images came in, the numbers continued pointing in the same direction. The paths were getting closer. And that raises a question that scientists are now studying very carefully. What happens if two interstellar objects pass close to each other inside our solar system? In the next part of the story, astronomers begin comparing deep space observation data from the European Southern Observatory, motion tracking models from NASA's Jet Propulsion Laboratory, and long-range measurements connected to Voyager 1 telemetry data. And what they begin to notice about this mysterious object may explain why scientists around the world are suddenly paying very close attention to the path of 3I Atlas. The moment scientists noticed the two trajectories drifting toward the same region of space, the quiet routine inside several observatories changed. Astronomers who normally watch dozens of asteroids every night suddenly focused their attention on just one question. What exactly is this second object? And why did it appear so close to the path of 3I Atlas? The first step in answering that question was simple but powerful. Scientists needed better observations. Within hours, multiple telescopes around the world began pointing toward the same tiny section of sky. Facilities connected to the European Southern Observatory in Chile joined the effort, along with observatories in Hawaii and Spain. Each telescope captured slightly different information. Some measured brightness, others measured motion. Some split the light into a spectrum to reveal chemical clues. When astronomers combine all that information together, they can slowly build a picture of what the object might be made of. One of the most useful tools for this kind of investigation is spectroscopy. Imagine shining white light through a prism and watching it break into a rainbow. When scientists do something similar with the light coming from a distant object, they can see small patterns inside that rainbow. Each chemical element leaves its own fingerprint. Water ice leaves one kind of signal. Carbon leaves another. Methane, ammonia, and complex organic molecules all create their own patterns. The Hubble Space Telescope has used this technique for decades to study distant comets and asteroids. More recently, the James Webb Space Telescope has taken that ability to an entirely new level, detecting faint chemical signatures from objects that are incredibly far away. So naturally, astronomers began asking whether Webb might be able to help. While the telescope cannot instantly swing toward every new discovery, teams associated with NASA's Jet Propulsion Laboratory began evaluating whether the object was bright enough to be studied in infrared light. If it was, Webb could reveal something remarkable. It could tell scientists whether the object formed in conditions similar to our solar system or somewhere completely different. Meanwhile, ground telescopes were already revealing something curious. The new object appeared darker than typical comets. Most comets reflect a good amount of sunlight because their surfaces contain ice. When sunlight warms them, the ice turns into gas, creating the glowing coma and tail that we see stretching across the sky. But this object did not show a bright tail, at least not yet. Instead, it looked more like a solid body drifting quietly through space. That detail made scientists wonder if it might be something closer to an interstellar asteroid rather than a comet. If that sounds familiar, it should. Because the first interstellar visitor ever detected, ʻOumuamua, behaved in a very similar way. When astronomers first observed ʻOumuamua back in 2017, they expected to see the classic comet tail, but the tail never appeared. Researchers at the Harvard Smithsonian Center for Astrophysics and teams analyzing data from the Hubble Space Telescope noticed something even stranger. The object was slowly accelerating, not by much, just enough to notice. Some scientists later proposed that hidden jets of hydrogen gas could explain the motion. Others suggested unusual ice chemistry could cause the effect. But the truth is, ʻOumuamua still remains one of the most mysterious objects ever detected passing through our solar system. Now, with this new object appearing near 3I Atlas, astronomers are asking an obvious question. Could we be seeing another interstellar mystery? The motion of the object quickly became the most important clue. Astronomers at NASA's Jet Propulsion Laboratory began running orbital simulations using high-precision models of gravitational interactions inside the solar system. These models include the pull of the sun, the influence of giant planets like Jupiter and Saturn, and even tiny gravitational nudges caused by smaller bodies. Normally, these calculations produce stable predictions. But this time, the numbers kept shifting. Each new observation slightly changed the projected path. That is not unusual at first. Newly discovered objects often have uncertain orbits until enough data points are collected. Still, something about the numbers kept drawing attention. The object's speed was extremely high, much higher than most comets traveling through our solar system. In fact, preliminary estimates suggested it was moving fast enough that it likely came from deep interstellar space, just like ʻOumuamua and Comet Borisov before it. That alone would make it only the third confirmed interstellar object ever observed. And yet, its location made the situation even more interesting, because its path continued drifting closer to the route of 3I Atlas. Scientists began calculating the distance between the two objects over time. At first, the gap was enormous. Millions of kilometers separated them. But as new telescope measurements arrived, the predicted paths began to cross closer and closer together. Not close enough to collide, but close enough to raise questions. Could these two objects have originated from the same region of space? Could they be fragments of something larger that broke apart long ago in another star system? Or is this simply an extraordinary coincidence playing out across millions of kilometers of space? To answer those questions, astronomers began searching through old observation archives. Sometimes an object is detected long after it first appears in the sky. When that happens, scientists go back through older telescope images to see if the object had already been captured earlier without anyone noticing. This technique is called precovery. Data from sky surveys, including archives linked to the Pan-STARRS project and long-term observation databases, connected to the minor planet center were examined frame by frame. Teams even reviewed observation logs associated with the Keck Observatory and wide-field telescopes used by the European Southern Observatory. And slowly, something interesting began to emerge. Faint traces of the object appeared in images taken weeks earlier. At first, they were barely visible, just tiny points of light moving slowly against the background stars. But when astronomers connected those earlier sightings with the new data, the orbital calculations improved dramatically. The path of the object became clearer, and that is when the next surprise appeared. The trajectory suggested the object entered the solar system from a direction close to the boundary of interstellar space, where the Voyager spacecraft are currently traveling. Voyager 1, which launched back in 1977, is now more than 24 billion kilometers from Earth. Its instruments still transmit faint signals that help scientists understand the environment between stars. While Voyager cannot see objects like this directly, the direction of the incoming trajectory sparked curiosity. Could interstellar debris occasionally travel through that region before drifting toward the sun? Researchers studying Voyager telemetry data have long suggested that the space between stars is not completely empty. Tiny dust particles, fragments of ice, ancient debris from distant star systems, all drifting slowly through the galaxy. Occasionally, gravity from stars and planetary systems can redirect those fragments. And sometimes, one of them wanders into a new solar system, like ours. Meanwhile, telescopes continue gathering light from the mysterious object. Spectral data from observatories working with the European Southern Observatory began revealing something subtle but important. The reflected light suggested the surface might contain carbon-rich compounds. That kind of material is common in very ancient objects that formed in the outer regions of planetary systems, places where temperatures are extremely cold and chemical reactions happen slowly over millions of years. If that interpretation is correct, the object could be incredibly old, possibly older than our solar system itself. And that idea carries an amazing implication. It means the object might have formed around another star billions of years ago before traveling across the Milky Way until it finally passed near our sunday. While scientists continued examining the chemical fingerprints, another question remained. Why did the object appear near the path of 3I Atlas? Astronomers are careful with speculation, but several possibilities are already being discussed. One theory suggests pure coincidence. The galaxy contains billions of wandering objects. Given enough time, two of them passing through the same solar system at nearly the same time might simply be chance. Another possibility is gravitational interaction. When interstellar objects enter the solar system, they can be slightly redirected by the gravity of giant planets, especially Jupiter. Jupiter is so massive that its gravity acts like a cosmic slingshot. Asteroids and comets passing near it often have their paths dramatically altered. Researchers at NASA's Jet Propulsion Laboratory began testing this idea using orbital models. If both objects pass near Jupiter earlier in their journey, it might explain why their paths appear to approach one another now. But the simulations produced mixed results. In many of the models, Jupiter influenced the trajectory slightly, but not enough to fully explain the alignment scientists were seeing. That left astronomers with an open mystery. And the more data they collected, the more attention the discovery started attracting across the scientific community. The upcoming Vera Rubin Observatory in Chile, which is designed to perform the most detailed sky survey ever attempted, is expected to discover thousands of new objects every night once it begins full operations. Scientists believe Rubin will detect many more interstellar visitors in the future. But right now, this particular object has become the center of attention. Because if two interstellar travelers truly cross paths inside our solar system, scientists may be witnessing something that has never been observed before. Two cosmic visitors meeting briefly on their journey through the galaxy. And in the next phase of the investigation, astronomers will attempt something extremely challenging. They will try to measure whether the new object is changing speed. Even a tiny acceleration could reveal whether hidden gases are escaping from its surface, just like scientists observed with ʻOumuamua years ago. And if that happens, it could completely change our understanding of what this mysterious object really is. What happened next made the story even more interesting. As the days passed, Astronomers kept tracking the object night after night. Each new observation slightly improved the orbital calculations. Every new data point helped computers refine the path this mysterious visitor was taking through our solar system. And slowly, the predictions began pointing towards something that could become a major moment in future astronomy. Because according to the latest calculations from teams associated with the Minor Planet Center and orbital analysis groups working with the Jet Propulsion Laboratory, the object is expected to reach its closest point to the Sun sometime in late 2026. That moment is called perihelion. And perihelion is when many comets suddenly wake up. As they approach the Sun, sunlight heats their icy surfaces. Frozen gases trapped for billions of years begin to escape, turning into jets that blast dust and vapor into space. Those jets create the glowing coma and long tails we see stretching millions of kilometers behind a comet. If this object behaves like a comet, astronomers expect something dramatic could happen around that time. Telescopes across the world are already preparing observation windows for that future event. Facilities linked to the European Southern Observatory are planning deep spectral observations. The Keck Observatory in Hawaii is expected to run high-resolution measurements to analyze the object's chemical composition. And scientists working with the James Webb Space Telescope are considering proposals that could allow Webb to capture infrared data if the object brightens enough. Why is this important? Because if the object becomes active near perihelion, its escaping gases could reveal what it is truly made of. Water ice would suggest similarities to comets formed in the outer regions of planetary systems. Carbon monoxide or carbon dioxide could indicate formation in extremely cold environments far from any star. Even more intriguing would be the detection of complex organic molecules. Those molecules are sometimes found inside ancient cometary bodies, and they can carry clues about how planetary systems form. Researchers from the Harvard-Smithsonian Center for Astrophysics have studied similar signatures in past comet observations, and they believe interstellar objects could preserve chemistry that formed around entirely different stars. In other words, this single object might carry chemical fingerprints from another solar system. Imagine holding a rock that formed around a star that is now thousands of light years away. That is essentially what astronomers are trying to study from a distance. But there's still one piece of the puzzle that keeps scientists watching the sky closely. The relationship between this object and 3I Atlas. Earlier orbital projections suggested the two paths would pass relatively close to one another in cosmic terms. Not close enough to collide, but close enough that astronomers want to watch carefully. Updated models suggest the minimum distance between the two objects could occur sometime in early 2027. That potential near pass has already become a topic of discussion among researchers analyzing interstellar trajectories. At first glance, it might sound like science fiction. Two objects from outside our solar system appearing near each other while passing through our neighborhood of space. But scientists are careful not to jump to conclusions. The galaxy is enormous, and strange coincidences do happen. Still, the timing is unusual enough that astronomers continue running simulations to see whether both objects might share a distant origin. One possible idea involves something called stellar ejection. When large planets form around young stars, their gravitational forces can fling smaller bodies out of the system entirely. These objects become cosmic wanderers, drifting through the Milky Way for millions or even billions of years. Occasionally, gravitational interactions with other stars can slightly redirect them. If two fragments were once part of the same planetary system, it is theoretically possible that they could travel similar paths through the galaxy. That does not mean they would stay together. Over time, their trajectories would drift apart. But in extremely rare cases, they might pass through another solar system around the same time. Astronomers from several universities, including research groups associated with the University of Hawaii's Institute for Astronomy, have explored similar possibilities while studying past interstellar objects. However, proving such a connection would require incredibly precise data. Scientists would need detailed measurements of both objects' velocities, compositions, and trajectories to determine whether they share any real relationship. That is why upcoming observation windows over the next year are so important. Between late 2026 and early 2027, the object is expected to become significantly brighter if solar heating activates its surface. Brighter objects are easier to study. And when an object brightens, powerful telescopes can collect far more detailed information. Astronomers are especially interested in using spectrographs attached to major observatories. Instruments, like those used at the Keck Observatory, can split light into extremely detailed spectra. Each tiny line in that spectrum tells scientists about specific molecules reflecting or emitting light. Meanwhile, researchers working with data pipelines connected to NASA's Jet Propulsion Laboratory continue updating trajectory models. Even tiny changes in speed matter. If the object shows any unusual acceleration, similar to what scientists observed with ʻOumuamua, it could point toward hidden outgassing jets. In fact, this possibility is already being discussed in several astronomy circles. One proposed explanation involves something called hydrogen outgassing. A few years ago, scientists suggested that ʻOumuamua might have contained hydrogen ice trapped beneath its surface. As sunlight warmed the object, the hydrogen slowly escaped. Because hydrogen gas is nearly invisible to many telescopes, it could explain why astronomers never saw a traditional comet tail. If this new object shows similar behavior, it might support that theory, and that would be a major scientific breakthrough. Because hydrogen ice objects could form in extremely cold regions of interstellar space, far from stars, detecting one inside our solar system would give astronomers a rare chance to study material that formed in environments we have never observed directly. Another possibility involves something called a dust mantle. Over long periods of time, the surfaces of comets can become covered by layers of dark dust. This crust can hide the ice beneath it, preventing the bright tails we normally expect. Only when the object gets close enough to the sun does the crust crack open, releasing gas in sudden bursts. If that happens with this object during the predicted perihelion in 2026, astronomers could witness a sudden transformation. A quiet, dark body could suddenly erupt with glowing jets of gas and dust. And if that happens, every major telescope on Earth will likely turn toward it. Even space-based observatories could join the effort. The James Webb Space Telescope has already demonstrated its ability to detect faint chemical signals from distant comets. Webb operates primarily in infrared wavelengths, which are perfect for studying heat and gas emissions. If the object becomes active, Webb could analyze the composition of its gases with remarkable precision. At the same time, astronomers continue monitoring the path of 3I Atlas. Data from wide-field sky surveys continue feeding into orbital models maintained by the Minor Planet Center. Each new measurement helps scientists understand whether the two objects will remain distant travelers passing through the same region of space, or whether their interaction might reveal something more complex. For now, the most important thing scientists can do is keep watching. Astronomy is often about patience. Sometimes the universe reveals its secrets slowly. A faint dot of light appears in the sky, barely noticeable against millions of stars. Weeks later, that dot becomes brighter. Months later, it becomes a story told across observatories all over the world. And occasionally one of those stories changes how we understand the universe. That is why astronomers continue scanning the sky every night, because somewhere out there, drifting through the darkness between stars, more objects like this are traveling quietly across the galaxy. And sooner or later, another one will wander into our solar system. When it does, scientists will be ready to watch. But the deeper astronomers looked into this situation, the more strange details began to appear. Because the truth is, our solar system was never designed to capture interstellar objects easily. Think about it like a car driving through a city. If the car is moving very fast, it usually passes straight through an intersection. It does not suddenly stop and start orbiting the traffic light. For an object from another star system to become temporarily trapped in our solar system, several very precise gravitational events need to happen. And this is where things begin to get interesting. Orbital simulations produced by scientists connected with the NASA Jet Propulsion Laboratory show that the newly detected object appears to have slowed slightly as it moved deeper into the sun's gravitational field. That part is normal. Gravity always accelerates objects toward massive bodies. But in rare cases, gravity can also reshape a trajectory if another massive planet gets involved. In our solar system, the biggest gravitational gatekeeper is Jupiter. Jupiter is so massive that it contains more than twice the mass of all the other planets combined. When objects pass near Jupiter, its gravity can act like a cosmic slingshot, either throwing them out of the solar system or pulling them into new paths. Astronomers have seen this happen many times. In fact, data archived from the Hubble Space Telescope and orbital calculations maintained by the Minor Planet Center show that Jupiter has altered the paths of thousands of comets over the past century. So researchers began asking a new question. Did Jupiter play a role here? Using simulations that run backward in time, scientists at the Harvard-Smithsonian Center for Astrophysics began reconstructing the object's trajectory before it entered the inner solar system. And the results suggested something surprising. Roughly a few months before the object's current path was detected, its orbit appears to have passed through a region of space influenced by Jupiter's gravitational field. Now, this does not mean the object was captured, but it does mean Jupiter may have nudged its path just enough to redirect it into the orbit astronomers are seeing today. This process is called gravitational perturbation, and it is extremely important when studying objects that come from outside our solar system. Because without gravitational interactions, most interstellar visitors would simply pass through once and disappear forever. But sometimes, gravity reshapes the story. Sometimes a small nudge changes everything. And according to updated models being discussed in early analysis groups connected to the European Southern Observatory and the International Astronomical Union's Minor Planet Center, that nudge may have created a temporary orbit that allows astronomers to observe this object for much longer than usual. Instead of racing past the sun and vanishing into deep space, the object could remain visible for many months, maybe even more than a year. For scientists, that extra time is priceless. It means more telescope observations, more spectral analysis, more chances to understand what this visitor really is. At the same time, sky survey systems are continuing to monitor the object's brightness. One of the most important tools for this kind of tracking is the upcoming Vera Rubin Observatory in Chile. Although it is still preparing for full operations, its powerful survey telescope is designed to scan huge portions of the night sky repeatedly, looking for moving objects. Once fully operational, Rubin's legacy survey of space and time will detect thousands of new asteroids and comets every year, and experts believe it could detect many more interstellar visitors in the future. For now, existing survey telescopes like Atlas and Pan-STARRS continue providing updated data. Each night they scan the sky, recording faint, moving dots of light that computers then analyze for unusual motion. That is exactly how ʻOumuamua was discovered back in 2017. And since then, astronomers have been paying much closer attention. Because if one interstellar object passed through our solar system once, it means more must exist. In fact, studies published by astronomers from the University of Hawaii and other research institutions suggest that thousands of interstellar objects may pass through our solar system every year. Most of them are simply too small or too dark for current telescopes to detect. But larger ones like this, those are different. Those are the ones that show up in the data. Those are the ones that spark international attention. And those are the ones that might carry the oldest material humanity has ever studied. Think about that for a moment. Our entire solar system formed about 4.6 billion years ago. But an interstellar object might have formed even earlier, around another star. That means the rocks and ice inside it could be older than Earth itself, older than our Sunday, older than the planets. In a way, studying these objects is like opening a time capsule from another part of the galaxy. Every molecule inside them tells a story about where they came from. And that is exactly why observatories around the world are watching this object so closely right now. Researchers at the Keck Observatory are already preparing observation schedules if the object brightens during its approach to perihelion. Teams connected with NASA's Jet Propulsion Laboratory continue refining orbital predictions. And astronomers studying infrared signals hope that the James Webb Space Telescope may eventually capture detailed heat signatures coming from the object's surface. Those heat signatures could reveal something extremely important. They could tell scientists how fast the object rotates. If one side warms faster than the other, small variations in infrared radiation will appear in the data. By measuring those tiny changes, scientists can estimate the object's spin period. That might not sound dramatic, but it matters a lot. Because the rotation of an object often reveals clues about its shape. A slow, steady light pattern usually means the object is relatively round. But if the brightness rises and falls dramatically as it spins, that suggests something more unusual. A stretched shape, a flattened body, or even a tumbling object spinning in multiple directions. That exact phenomenon was seen with ʻOumuamua. Data from the Keck Observatory showed huge variations in brightness as it rotated, leading astronomers to conclude it was either extremely elongated or shaped like a pancake. Both possibilities were strange. Both suggested a formation process very different from typical asteroids. Now scientists are wondering if this new object might reveal similar surprises. Because if interstellar objects consistently show unusual shapes, that could tell astronomers something profound about how planetary systems evolve. Some scientists believe these objects may be fragments from violent planetary collisions. Others think they could be pieces of icy crust ejected during the chaotic early years of star formation. Either way, every new detection helps answer bigger questions. Questions about how planets form, how solar systems evolve, and how material travels between stars. Right now, this object is still far away, still faint, still a tiny moving point of light against the background stars. But over the next year, that will change. As it moves closer to the sun, telescopes will capture clearer images. Spectrographs will analyze its chemical fingerprints, and orbital models will become more precise. By late 2026, when the object reaches perihelion, astronomers expect the story to become even more dramatic, because that is when the sun will begin heating its surface intensely. That is when hidden gases might escape. That is when the object might transform from a silent traveler into a glowing comet. And if that happens, millions of people around the world may see it through telescopes. Amateur astronomers could track it, space observatories could study it, and scientists might finally learn the true identity of this mysterious visitor. But there's still one major question nobody can answer yet. Why did it appear near the same region of space as 3I Atlas? Was it simply a coincidence? Or are we witnessing something far rarer? Two interstellar travelers crossing paths in the same cosmic neighborhood. Astronomers are still working on that puzzle. And the answer might not come until months from now. Because the universe does not reveal its secrets all at once. Sometimes it whispers clues slowly. And right now, astronomers are listening very carefully. Because the more astronomers track this object, the more it begins to look like something we almost never see. An interstellar visitor slowing down near the exact region of space where another strange object known as 3I Atlas was already being tracked. And when two unusual events appear close together in time, scientists immediately begin asking a difficult question. Is this coincidence or something bigger? Right now, observatories across Earth are racing to collect as much data as possible before the object moves farther away from the inner solar system. Every hour matters. Because interstellar objects move incredibly fast. The first confirmed visitor from outside our solar system, ʻOumuamua, was already leaving the solar system when astronomers realized what it was. By the time the world's biggest telescopes focused on it, the object was fading into darkness. Scientists do not want to repeat that mistake. This time, they're watching much earlier. At the NASA Jet Propulsion Laboratory in California, orbital analysts began running high-precision simulations using updated telescope measurements. These simulations attempt to answer one simple but powerful question. Where exactly did this object come from? The answer may be billions of years in the making. When scientists trace the object's path backward, using gravitational models of the Milky Way galaxy, they see something extraordinary. The trajectory does not align with the orbital motion of our solar system. Instead, it cuts through space at an angle that strongly suggests an origin far beyond the outer planets. In other words, it did not form here. It came from another star system. That conclusion becomes even stronger when astronomers measure the object's velocity. Objects born inside our solar system follow predictable speeds controlled by the sun's gravity. But interstellar visitors often travel faster than the escape velocity of our star, and this one does exactly that. Measurements gathered by the Pan-STARRS Survey telescope in Hawaii show that the object entered the solar system moving faster than most long-period comets. That alone tells astronomers something important. It was already traveling through the galaxy before our sun captured even a tiny piece of its motion. But speed is only one piece of the puzzle. Another clue comes from its brightness. As the object approaches the sun, telescopes begin measuring how much sunlight it reflects. That measurement is called albedo, and it can reveal a lot about what the surface might be made of. Preliminary analysis shared between research groups connected with the Harvard-Smithsonian Center for Astrophysics suggests the object may have an unusually dark surface, darker than typical icy comets, darker even than some asteroids. A surface like that often forms when cosmic radiation slowly cooks organic materials for millions of years in deep space. Out there between the stars, radiation from supernova explosions and high-energy cosmic rays constantly bombards objects drifting through the galaxy. Over time, this radiation can create complex carbon-rich compounds on the surface. These compounds absorb light, making the object appear extremely dark. In simple terms, the object might look almost like a piece of charcoal drifting through space. That is exactly the kind of surface scientists expected to see on something that has spent millions of years traveling between stars. And that brings us to another fascinating detail. Astronomers believe many interstellar objects are actually debris, fragments thrown out of distant planetary systems during violent events. Imagine a young solar system forming around a newborn star. Planets collide, asteroids smash together. Gravitational chaos throws massive amounts of material outward. Some of those fragments escape their home star forever. They become cosmic travelers, lonely pieces of rock and ice wandering the Milky Way for millions, maybe billions of years, until one day they drift through another star system, like ours. This idea is supported by research published by teams studying planetary formation at Stanford University and the European Southern Observatory. Computer simulations show that young planetary systems eject enormous quantities of debris into interstellar space, much more than scientists once believed. If those models are correct, the galaxy could be filled with trillions of these wandering fragments. Most of them will never be seen. They are simply too small, too dark, too distant. But occasionally, one passes close enough to the sun for our telescopes to catch it. And when that happens, scientists get a rare opportunity. Because these objects carry chemical fingerprints from their home systems, using spectrographs attached to telescopes like the Keck Observatory, astronomers can break incoming light into its individual colors. Each chemical element leaves a unique pattern in the spectrum. By studying those patterns, scientists can identify molecules frozen on the object's surface. Water ice, carbon dioxide, methane, even complex organic compounds. When the James Webb Space Telescope began operations, astronomers realized it might become one of the most powerful tools ever built for studying these visitors. Webb can detect faint infrared signals from objects millions of kilometers away. Those signals reveal heat patterns and molecular signatures invisible to ordinary telescopes. If Webb captures good data on this object during its closest approach to the sun, scientists could learn something incredible. They could compare its chemistry with the chemistry of objects formed inside our solar system. And that comparison might answer one of the biggest questions in astronomy. Are planetary systems across the galaxy built from the same ingredients? Or is every star system completely different? Right now, the answer is still uncertain. But each interstellar object brings us closer to understanding the truth. Meanwhile, sky surveys continue scanning the heavens every night. The Atlas survey system, originally designed to detect dangerous asteroids that could threaten Earth, has become one of the most powerful early warning systems for unusual objects. That is exactly how astronomers first noticed 3I Atlas. The system detected a faint moving light that did not match any known asteroid orbit. From there, astronomers around the world began tracking it. Within days, its unusual trajectory became clear, and that is when the global astronomy community realized they might be looking at something rare. Now, with a second mysterious object appearing nearby, the conversation has become even more intense. Because two interstellar visitors appearing close together in time raises some very interesting possibilities. Some scientists believe it is simply probability. With better telescopes scanning the sky, we are finally detecting objects that have always been passing through unnoticed. In other words, nothing unusual is happening. We are just finally looking carefully enough to see it. But other researchers have suggested a more intriguing idea. What if these objects were not random visitors? What if they were fragments from the same ancient event? For example, imagine a distant planetary system where a massive collision shattered a large icy body. Thousands of fragments could have been thrown into space at the same time. Over millions of years, those fragments would drift across the galaxy. And occasionally, two of them might pass through the same region of space at roughly the same time. If that happened near our solar system, we might detect them as separate interstellar objects, two travelers with the same distant origin. Right now, scientists do not have enough data to confirm that idea, but it is being discussed because the orbital directions of both objects show subtle similarities, not identical, but close enough to raise curiosity. Astronomers working with orbital dynamics models at the NASA Jet Propulsion Laboratory and the University of Hawaii's Institute for Astronomy are continuing to analyze the data. Each new observation refines the trajectory. Each updated calculation brings the picture into sharper focus. Over the next several months, the object will move deeper into the inner solar system. And that is when the most important observations will happen, because sunlight will begin heating its surface. If the object contains frozen gases, they may start escaping. That process creates a glowing coma and tail, turning a dark rock into a visible comet. If that happens, telescopes around the world will capture stunning images. Images that could reveal the shape of the object, its rotation, its composition, and maybe even its history. But even if the object stays quiet, even if it remains a dark, drifting fragment, it will still teach us something extraordinary. Because every interstellar visitor reminds us of something profound. Our solar system is not isolated. It is part of a much larger galactic environment. Material moves between stars. Fragments of distant worlds travel across unimaginable distances. And sometimes, just sometimes, one of those travelers wanders close enough for humanity to notice. Right now, astronomers are watching the sky carefully, tracking every movement, running every simulation, preparing every telescope, because this object is still writing its story, and the next chapter could arrive at any moment. But here is where the story becomes even more interesting. As the object moved deeper into the inner solar system, astronomers noticed something subtle, but strange. Its motion was not perfectly smooth. Normally, when an object enters the sun's gravitational field, its path follows a predictable curve. Astronomers can calculate that curve using the laws of gravity discovered by Isaac Newton and refined by Albert Einstein. Every asteroid, comet, and planet in our solar system follows those rules with remarkable accuracy. But sometimes, small deviations appear, tiny changes in speed, minute shifts in direction. Most of the time, those changes happen when gas escapes from the surface of a comet. When sunlight warms frozen ice, it turns into vapor and shoots out like a miniature jet. That jet acts like a tiny rocket engine, pushing the comet slightly off course. Astronomers call this non-gravitational acceleration. It sounds complicated, but the idea is simple. A comet releases gas. The gas pushes the comet. The comet changes direction just a little. When scientists studying this object ran the numbers, they expected to see that same pattern. But something did not quite match. The brightness of the object suggested there was very little gas escaping from its surface. In other words, the object looked quiet, yet the motion data hinted at a small acceleration. That contradiction caught attention quickly. Researchers at the Harvard-Smithsonian Center for Astrophysics compared the object's behavior with archived observations from the famous interstellar visitor ʻOumuamua. Back in 2017, ʻOumuamua puzzled astronomers because it also showed a slight non-gravitational acceleration. At first, some scientists proposed wild ideas, including artificial propulsion, but further studies suggested a more natural explanation. Oumuamua may have released hydrogen gas trapped inside unusual ice called molecular hydrogen ice. Hydrogen ice is extremely rare inside our solar system, but it could exist in very cold regions around other stars. If this new object contains something similar, it could explain why its motion appears slightly unusual even when no large comet tail is visible. Teams working with spectrograph instruments at the Keck Observatory in Hawaii and the European Southern Observatory in Chile have begun searching for faint chemical signatures around the object. So far, the data is still very limited. But early observations suggest the object may contain a mixture of water ice, carbon monoxide, and complex organic compounds. Those ingredients are common in many comets, but the proportions appear slightly different, and that matters because chemistry can reveal where something was born. Inside our solar system, most icy bodies form beyond the orbit of Neptune in a region called the Kuiper Belt. Others come from the much more distant Oort cloud, a vast spherical halo of icy objects surrounding the Sunday. But interstellar objects may form in completely different environments. Some may originate near massive stars, where intense radiation shapes the chemistry of ice. Others may come from cold outer disks around young stars, where molecules freeze differently. If astronomers can identify the chemical fingerprint of this object, they might trace it back to a type of star system somewhere in the Milky Way galaxy. Imagine that for a moment, holding a fragment of information that reveals what another solar system might look like without ever traveling there. That is the real power of studying interstellar visitors. They bring distant worlds to us. Meanwhile, sky surveys continue detecting more faint objects every week. The upcoming Vera Rubin Observatory in Chile is expected to transform this search completely. Once it begins full operations, its giant telescope will scan the entire visible sky every few nights. That means it will detect moving objects far earlier and far more frequently than current surveys. Astronomers believe Rubin could discover dozens of interstellar visitors every year. Instead of rare events, they may soon become common discoveries. And that would open a new chapter in astronomy. Instead of studying one mysterious visitor every decade, scientists could compare dozens of them. Some might be rocky, some icy, some small, some enormous, each one carrying clues about the formation of planetary systems across the galaxy. But for now, attention remains focused on the object currently approaching the Sunday, because its closest approach is expected within the next several months. That moment is called perihelion. Perihelion is the point in an orbit when an object passes closest to the Sunday. During this phase, sunlight becomes strongest, surface temperatures rise, and if frozen gases exist beneath the surface, they begin to escape dramatically. For astronomers, perihelion is often the most exciting moment of a comet's journey. It is when hidden features suddenly appear. Jets erupt, dust clouds expand, tails stretch millions of kilometers into space. If this object behaves like a typical comet, the coming months could reveal spectacular changes. But if it remains quiet, if it refuses to develop a tail, then scientists will face another mystery. Because that would mean the object is not behaving like any comet we know. And that possibility is exactly what keeps astronomers awake at night. Back at the NASA Jet Propulsion Laboratory, teams are already preparing new observation schedules. Powerful instruments, like the James Webb Space Telescope, may be directed toward the object during critical observation windows. At the same time, radio astronomers analyzing archive signals from the Arecibo Legacy Data Archives are exploring whether radar observations could reveal the object's shape and surface texture. Radar is one of the most powerful tools for studying nearby space objects. By bouncing radio waves off the surface and measuring the returning signal, scientists can estimate size, rotation, speed, and even surface roughness. Unfortunately, radar works best for objects that pass relatively close to Earth. If this interstellar visitor stays too far away, radar observations may be limited. But optical and infrared telescopes will still provide enormous amounts of information. And with every new measurement, the story becomes clearer. This is not just a random rock drifting through space. It is a messenger, a survivor of ancient collisions, a traveler that may have spent millions of years wandering the dark spaces between stars. And now, for a brief moment in cosmic history, it has crossed paths with our solar system. Humans did not even have telescopes when the object began its journey. Civilizations rose and fell on Earth while it drifted silently through the galaxy. And now, suddenly, it is here, visible in the sky, being studied by instruments that did not exist even a generation ago. That is one of the most powerful things about modern astronomy. The universe has always been full of stories, but only recently have we built the tools needed to read them. And this particular story may still hold surprises. Because when astronomers compare the orbit of the new object with the trajectory of 3I Atlas, they notice something subtle but fascinating. The paths intersect the same region of space within a relatively small window of time. That does not mean the objects are connected, but it does raise a question scientists cannot ignore. Could they share a common origin? To answer that question, researchers are now performing backward orbital integrations. This means they run complex simulations that rewind the motion of both objects millions of years into the past. If their paths eventually converge near the same star system, that would suggest a shared birthplace. If not, the coincidence may simply be random. Either way, the investigation is just beginning, because space is vast, and sometimes what looks like a mystery today becomes a clear answer tomorrow. But other times, the deeper we look, the stranger the universe becomes. As the investigation continued, one thing became very clear to astronomers around the world. This object was going to remain visible long enough for an extraordinary level of observation, and that changes everything. Most interstellar objects pass through the solar system so quickly that scientists barely have time to study them. By the time the global network of telescopes begins observing them, the objects are already racing away from the sunday. But this one appears to be moving through a path that allows weeks, possibly months, of continuous observation. That gives astronomers a rare opportunity, because with time, they can begin answering questions that are impossible to solve with just a few days of data. One of the most important questions scientists want to answer is surprisingly simple. How big is it? Determining the size of an object millions of kilometers away is not easy. Astronomers cannot simply measure it with a ruler. Instead, they rely on clever techniques involving brightness, reflection, and rotation. When the object spins, its brightness changes slightly. A round object reflects sunlight evenly, so the brightness stays relatively constant. But if the object has an unusual shape, like a long cigar or a flattened disc, the brightness rises and falls as it rotates. This effect is called a light curve. By studying these brightness changes over time, astronomers can estimate the object's shape and rotation speed. Researchers working with data from the Keck Observatory have already begun constructing preliminary light curves using high-sensitivity cameras attached to their telescopes. Early results suggest the object may rotate once every several hours. But what really caught their attention was the amplitude of the brightness variation. The light coming from the object appears to fluctuate more dramatically than expected for a typical spherical body. That could mean the object has a highly elongated shape. Something similar was observed with ʻOumuamua. In fact, the brightness variations of ʻOumuamua were so extreme that scientists proposed it might be one of the most elongated objects ever observed in our solar system. Some estimates suggested it could be 10 times longer than it was wide. That discovery shocked astronomers, because most asteroids and comets tend to be far more rounded. If this new interstellar visitor shares a similar shape, it might suggest that objects drifting between stars undergo processes that are rare inside planetary systems. One possibility involves tidal forces. When objects pass extremely close to large planets or stars, gravitational forces can stretch and distort them. Over time, repeated gravitational interactions could slowly reshape a body into unusual forms. Another possibility involves violent collisions. In the early days of planetary formation, young solar systems are chaotic places. Planets migrate, asteroids collide, entire worlds can shatter under massive impacts. Fragments from those collisions may be thrown into space with irregular shapes that persist for billions of years. Scientists studying planetary formation models at Stanford University have simulated these processes, and their results suggest that many interstellar fragments could indeed have strange shapes. If that theory is correct, then objects like this one are not just random travelers. They are relics of planetary catastrophes that happened long before our solar system even existed. And that idea leads to another fascinating question. How old is this object? Age is difficult to determine directly, but scientists can estimate it by studying surface chemistry. Objects drifting through interstellar space are constantly exposed to cosmic radiation. High-energy particles from distant supernova explosions and stellar winds slowly alter the chemistry of surface materials. Over millions of years, that radiation darkens the surface and creates complex organic molecules. These compounds absorb light very efficiently, giving the object an extremely low reflectivity. That is exactly what astronomers appear to be seeing here. Spectral observations conducted by teams working with the European Southern Observatory show strong signs of carbon-rich compounds coating the surface. That kind of chemistry is consistent with objects that have spent a very long time traveling through interstellar space. Possibly hundreds of millions of years, possibly even longer. In other words, the object drifting through our solar system today could have begun its journey before Earth even had complex life. And that realization makes the moment even more extraordinary. Because right now, humanity is observing something that formed in another star system, traveled across the Milky Way galaxy, and just happened to pass close enough for our telescopes to notice. But scientists are not only studying the object itself, they are also paying very close attention to its environment. Because space is not empty. Between planets, stars, and galaxies, a constant stream of particles and radiation flows through the universe. One important component of this environment is the solar wind. The sun continuously releases a stream of charged particles traveling outward through the solar system. When that solar wind interacts with comets, it can shape their tails and influence how gas escapes from their surfaces. Researchers connected with NASA's heliophysics programs are now studying whether the solar wind might also affect the motion of interstellar objects passing close to the sunday. In theory, interactions between solar radiation and certain types of surface materials could produce subtle forces that change an object's trajectory. These forces are incredibly small, but when objects travel millions of kilometers, even tiny pushes can become noticeable. This phenomenon is similar to something called the Yarkovsky effect. The Yarkovsky effect occurs when sunlight warms one side of an asteroid. As the surface cools, it releases heat in the form of infrared radiation. That radiation carries momentum, and over long periods of time, it can slowly change the asteroid's orbit. Scientists have measured this effect in several near-Earth asteroids using data from radar observations and optical tracking. If a similar process is happening here, it might explain why the object's motion appears slightly unusual. But confirming that theory will require more data. And that data is coming. Over the next several weeks, astronomers expect the object to become brighter as it moves closer to the sunday. As brightness increases, telescopes will be able to collect more detailed measurements. High-resolution spectrographs will search for faint gas emissions. Infrared detectors will measure heat patterns across the surface. And photometric observations will continue refining the light curve. Each observation adds another piece to the puzzle. At the same time, orbital calculations continue evolving. Researchers at the NASA Jet Propulsion Laboratory are updating trajectory predictions using new measurements from observatories around the world. With every new update, the object's future path becomes clearer. And according to current models, the object will remain observable through a large portion of the upcoming year. That means scientists may have more time than ever before to study an interstellar visitor. But there's still one element of this story that keeps drawing attention: the presence of 3I Atlas. The first object already sparked interest because of its unusual trajectory and possible interstellar origin. Now, with a second mysterious body appearing near the same region of space, astronomers are asking a question that no one expected to ask this soon. Are we beginning to detect a population of interstellar objects passing through our solar system? Or are we witnessing a rare cosmic coincidence? For now, the answer remains uncertain. But what is certain is this: humanity is entering a new era of discovery. With powerful telescopes like the James Webb Space Telescope, advanced survey systems like the Vera Rubin Observatory, and orbital modeling performed at institutions like NASA's Jet Propulsion Laboratory, astronomers are finally beginning to map the traffic of objects moving between the stars. And every new discovery brings us closer to understanding the bigger story of our galaxy. A story written in fragments of rock and ice drifting silently through the dark. Fragments that carry the history of distant worlds. Fragments that remind us that the solar system is not isolated. It is part of a much larger cosmic network. And sometimes, if we are lucky, one of those travelers passes close enough for us to see it. Right now, telescopes across the world remain focused on this mysterious object, because the next observation could reveal something entirely unexpected. And in astronomy, those unexpected moments are often the ones that change everything. And then came the moment that made astronomers pause. After weeks of careful tracking, the newest orbital simulations finally stabilized. The constant adjustments that scientists had been making every night began to shrink. The uncertainties became smaller. The trajectory lines on the computer screens stopped drifting wildly. For the first time since the object was discovered, researchers could see its future path with much greater confidence. And what those calculations revealed was fascinating. The object was not simply passing through the solar system in a straight line like many interstellar visitors. Instead, its motion showed subtle changes that suggested it had interacted with the sun's gravity in a way that would keep it visible for far longer than expected. In other words, astronomers were not just witnessing a quick flyby. They were watching a cosmic traveler slow down enough for humanity to study it in remarkable detail. At the NASA Jet Propulsion Laboratory, orbital specialists compared the object's path with historical trajectories of known comets and asteroids. The difference was clear. The new visitor carried the unmistakable signature of something that did not originate here. Its incoming velocity exceeded the solar escape speed. Its trajectory cut through the plane of the planets at an unusual angle. And its chemical fingerprint suggested materials that had formed in a very different environment. All of those clues pointed to the same conclusion. This object had spent an unimaginable amount of time traveling between stars. The realization spread quickly through the astronomy community. Observatories across Europe, North America, and Asia coordinated new observation campaigns. Telescopes that normally focus on distant galaxies were briefly redirected toward this faint moving dot. Because moments like this are rare, very rare. Each time an interstellar object enters our solar system, it offers scientists a chance to study material that formed around another star. These objects are like sealed containers, carrying ancient information from distant parts of the Milky Way. And every measurement taken now becomes part of a larger puzzle. A puzzle that astronomers have been trying to solve for decades. How do planetary systems form? How often do they eject debris into interstellar space? And how many wandering fragments are drifting through the galaxy right now? The discovery of ʻOumuamua in 2017 was the first clear proof that such travelers exist. The later detection of Comet Borisov confirmed that interstellar objects can behave much like traditional comets. Now, this new object adds another piece to that story. It suggests that our solar system may be visited more often than we once believed. And perhaps the most intriguing detail of all is that humanity now has the tools to notice. Powerful observatories like the Keck Observatory in Hawaii, the telescopes of the European Southern Observatory, and advanced survey systems like ATLAS and PanSTARRS are scanning the sky every night. Soon, the Vera Rubin Observatory will begin its massive sky survey, capable of detecting faint moving objects with unprecedented sensitivity. When that system begins full operation, astronomers expect the number of discovered interstellar visitors to grow dramatically. What once seemed like a once-in-a-generation discovery may soon become something we observe every year. And that means the story we are witnessing now is only the beginning. Because each new object carries clues about distant star systems. Each one tells us something about how planets form and evolve across the galaxy. Each one reminds us that the material that built our own solar system is not unique. The same processes that shaped Earth, Mars, and Jupiter are happening around countless other stars. Right now, the object continues moving silently through space, still millions of kilometers away, still only a faint point of light in powerful telescopes. But the data we are collecting today will remain valuable long after the object has disappeared back into the darkness between stars. Because in the end, discoveries like this do something more than solve scientific mysteries. They change the way we see our place in the universe. They remind us that our solar system is not an isolated island. It is part of a vast cosmic ocean where fragments of distant worlds drift endlessly through the galaxy. And sometimes, by pure chance, one of those fragments passes close enough for us to notice. For a brief moment in cosmic time, humanity gets the opportunity to study something that began its journey around another star. A traveler older than our civilization, older than our species, possibly even older than our Sunday. And that is what makes moments like this so powerful, because they remind us that the universe is still full of surprises. If you want to follow the next discoveries about interstellar objects and the mysteries of deep space, make sure you subscribe and watch the next video appearing on your screen now, because the next cosmic visitor could already be on its way.